Hello, testing. Yeah, good afternoon. Welcome back to this lecture. This lecture is still on we are still looking at the Kirchhoff voltage law. This is on slide number 11 of your lecture notes. Earlier, we talked about this Kirchhoff voltage law circuit, in which we say that the sum of the voltage drop across the entire circuit is equals to the supply, or the sum of the voltage drop equals to 0. This is something that we have looked at. Now moving on to look at page 12, we are given a circuit like this, example 4.3. We are asked to find the V3 and also the Vx. Right, I think we can look at this circuit, okay, and analyze it. And we notice that in this circuit there are two battery sources, namely the E1, which is 34 volts, and E2, which is 2 volts. And we have three resistors in series. So first of all, let's try and see how to solve this problem. First thing first, let's try and find what is V3, which is pretty straightforward, because what we can say is that we can find V3 because it's the sum of the voltage drop across the circuit here. So since the E1 is 34, so we are going to use 34, and we need to offset by this 2 volts battery here, which is connected in the opposite polarity, as you can see. So I will need to take 34 minus 2 equals to the sum of the rest of the voltages, which is 12 volt here, 6 volt here, and the V3 here. So if you rearrange this circuit, we find a V3 at the left hand side. We worked out that the V3 is equals to 14 volts. I hope you are clear with this part of the solving of this question. Let's take a look at the Vx. How do we get the Vx? Now, if you look at this Vx here, we're actually considering to look at the circuit on the right hand side here, as you can see. All right, as I can highlight here. So we are looking at this voltage here, which is 6 volt here, plus the V3 here, and the sum of the voltage drop. So Vx is actually equals to 6 plus V3 volts. So it's 6 plus 14, which is 20 volts respectively. Now let's take a look at this question here, which is example 4.4, which is on page 15. Alright, so you can see that we are asked to find the current across the circuit, determine the voltage E and also the resistance R1. Now we are given some parameters here, namely the power dissipation by this particular resistor, the 1 kilo ohm resistor, which is 144 milliwatt, and we don't have the current. So let's see how we solve it. So the simple solution to answer this is that we find what is the current first using the formula I squared. Power equals to I squared R, right? So we can calculate the I squared. So you have to, given the power is 144 milliwatt, and the resistors across that red color highlighted resistor is 1 kilowatt. So 1 kilo ohm. So we can calculate the current flowing through the circuit, which is 12 milliampere. Now subsequently, we will use the information that we've gathered, which is the current, to find the E, which is the supply voltage. So now if we know 1 kilowatt, you can take the current, which is 12 milliampere times 1 kilo ohm, because V equals to IR, Ohm's law, and we'll get the voltage drop 12 volts that is dropped across this resistor. So the sum of the voltage drop here in total will be 15 volt, which is this voltage here, plus 12 volt, which comes from this contribution of this voltage drop here, and 25 volt, which is given. So it works out that the E is 52 volts. Then we go on to find what is the resistor R1. Since we already know what is the current, which is current in the series circuit should be 12 milliampere, and we have the voltage drop, which is 15 volts here, we easily can find the resistor R1 using V equals to IR, and we take voltage divided by the current, which is this I here is 12 milliampere, and we get this resistor 1.25 kilo ohm. I hope this circuit is clear, and I will pause the recording here. Thanks.